Hey guys, this is Wojtek from Jolly Monster Studio, and today we're going to take a look at how to start implementing some puzzle elements within our game. Specifically, we're going to look at how to extend a static mesh component so we can make it move within our world, and that's going to be used for things like the door you can see here and the pressure plate. So when we step on it, you can see it goes down, you can see the door swings outwards. I put another pressure plate here that we can see kind of from this side how the windows open up. And this is going to give us an extensible class that we can use for other parts of our game where we need one or many different movable components. We're also going to look at how to leverage interfaces. So when I interact with one object, it examines the rest of the world, looks for specific interfaces to interact with, and affects those objects as we expand some of our triggers. So let's get started. Okay, so back in Unreal, we're going to have to create a couple of classes to support this little puzzle exercise we're going to do. So as you can see, we've got a little building that I slapped together here, and it has some windows, it's got a door, there's no pressure plate. So let's go ahead and start defining the classes that are going to make all this stuff work. So we're going to need a pressure plate class. So we're just going to go into C++ classes, new class, and this is going to be an actor class. So we're going to put this under props, and we're going to call this pressure plate trigger. So there's our first class. Okay, the next class we're going to need is the door actor that we're actually going to be interfacing with. So we're going to make this, I'm just going to make this an actor, and we're going to put it in the prop folder, and we're going to call this the moving mesh. Moving static mesh actor. So this is going to be any actor that has a static or movable static mesh component that we can interface with. Okay, so there's our two classes. Now let's go ahead and extend the static mesh component so we can actually make it move stuff. So you just select all classes and you look for static mesh component as our base class. You'll see there's a number of other instances off of that, and we're just going to use the base one there. So this is going to be our component folder, and this is the movable static mesh component. And while movable static may seem like an oxymoron, we do want to leverage static meshes in here versus skeletal meshes. So let's go ahead and create this class. Okay, and the last the last class we're going to create is an interface class, and that is going to allow us to interface between different actors together. So let's go ahead and create a new interface class, and I think it's here at the bottom. And we're going to put this in the interface folder, and we're going to call this our interactable interface. Okay, let's jump into Visual Studio and start fleshing out these components. Okay, so back in the editor, I've got the movable static mesh component header open, and we're going to start defining some of its properties and functions. So the first thing we want to do is we're actually going to override a couple of methods, so specifically the tick. And you'll notice there's a tick component instead of a tick on a component class. And the other one we're going to override is the begin play. Similar to our regular actors, we want to inject some of our tick-based logic as well as anything post-constructor within our begin play. Okay, we're also going to add a private variable to keep track of whether or not we're moving or not. So we're going to have a Boolean for that. We're also going to create a timeline, which we're going to use to move the objects along. That gives us some nice kind of curvatures where we can have slightly cleaner animations and just give more sort of dynamic behavior and energy to the thing we're trying to animate. So it's not just a linear sort of animation. So let's go ahead and bring in the f timeline struct, and this is going to be the move timeline. And always make sure to bring in any sort of headers that you need as part of your work. So we have moving. We're also going to need a boolean for did we trigger this this component. We're also going to keep track of the where we were and where we're going within our timeline definitions. So I'm just going to keep a float of the previous timeline value. And that might be it for these definitions. We're also going to add a couple of private functions. So we want two functions, one for changing the location of our mesh, and the other one for changing the rotation. And that is just because we're going to separate the movement logic to keep it kind of really simple within the blueprint. So you can either move, you can rotate, but you can't really do both. And if you do want to do both, then there's going to be a little bit more coding on your end. So we're going to do a update rotation method that takes in the current float value of the curve from the timeline we're processing. And we're going to do another one that is location, and that takes in a curve value as well. Okay, so we have these private methods. Let's define some editable properties on this object. So we need a curve, so our timeline can leverage that. So we're going to use a curve float. And we're just going to call this a move curve. So this is going to be a U property. We're going to make it defaults only, blueprint callable, or rather blueprint read only, and category is going to be movement. Okay, so that's going to be the curve we tied to the timeline. We're also going to let's add some actually enums that are going to let our class determine, are we rotating, are we changing the location, and which axes, as well as sort of which part of the rotator we're accessing. So we're going to create a blueprint type of enum. And we're going to call this eRotate axis. Okay. And this is going to be our yaw pitch roll. We're going to now create another one, another enum rather. Enum class E. Let's do the location axis. And this is going to be X, Y, Z. And another enum, which is going to be our actual movement type. So the thing that determines whether we're rotating or translating by location. Movement type. And this is going to be location, rotation. So there's our three enums. And we're going to bring these guys in as properties to our object. So this guy's going to be the movement type. We are also going to add in the rotate axis, the location axis, and actually a rotation axis. Getting some of these typos cleaned up as we're going along. Now, we don't want these properties to always be accessible. We want to limit them to either location or rotation. And that can be done using the meta tag, where we can say edit condition equals movement type. So this variable here equals location. So if we have this enum set, this property should become visible to us. Likewise, for the rotation one, we should say it only becomes accessible if we have rotation picked. So one of these guys will be selected by default, and then one of these guys should become highlighted within our editor. So I think that may be it for the properties. But actually, you know what? Let's do another one. I'm just going to copy this property header, and we're going to call this B is reversed. So do we want it to go up or down on the x-axis or the z-axis? Likewise for the rotations, do we want to go forwards or backwards? So this is going to give us a little bit of another handy switch that we can control. Okay, so for our public methods on this thing, we now want to trigger the move. So we're going to have a move method that is going to take the trigger boolean as an input, so we can control whether it's starting or stopping. And let's make this a blueprint callable function as well. Now we need two functions for the timeline when it's running, when it's ticking, and it's passing the values, and one for when it's finished doing its operation. So we're going to create some new functions, and this one's going to be called onMove. That's going to do something. And another one that is onMove finished. And this is going to be called at the end of our timeline, whenever it's done. And let's do a getter for the is moving, and one for the trigger. So we have accessors to get at those properties if for whatever reason we need to. So we're just going to say bool is moving, and we're going to return the is moving. And let's do another one for is triggered. Const return B is B is triggered, and then we'll just rename this variable below here. Okay, so we have our move, we have our onMove, onFinish. We're missing the constructor definition, so let's put that in here. There's our constructor. And I think this may be okay. So let's go into our C++ class and start defining these methods. So I'm going to bring in the constructor to component, begin play. Actually, we want all of these. Okay. Static mesh component. Perfect. So, as far as the constructor goes, we want to, by default, the component is not set to tick. So we need to enable that state by can you ever tick set to true. So we're going to make it tick by default, just so it can immediately get at the movable object definitions. If you want to make this a parameter when you actually interface with the object, then you turn on the tick. Totally up to you. I'm just throwing in the constructor for now. Okay, so I'm just going to move these methods around because I like begin play after my constructor before the tick, just from a pure OCD standpoint. And then we're going to say if we have the movement curve, start initializing the timeline that's actually going to interface with it. So we're going to do a timeline float, which is our timeline callback. And then we have on timeline event static, and this is going to be our finish callback. Okay, and now let's bind the our main function that's going to do something while we're ticking along our curve. It's going to be fname, and this is going to be on move. So that's the method we're referencing here, using the bind function. And then we're going to do timeline finish, bind u function, this fname, let's do this again. Oops. On move finish. Okay, so there's our two bound functions. And then on the movement timeline, we want to add the interpolated float value, which is going to be coming from the curve, and it's going to be passing that information to our on move callback. Move timeline, set timeline finish function is just going to take in our finish callback. So there is our move timeline initialized with our two callbacks. And I think that may be it for the tick. Or sorry, for the begin play. Now in the tick is when we actually want to move things along the timeline. So we're going to say if B is moving, then we want to say move timeline, and we want to tick the timeline by the delta time coming in. So that's going to move our timeline along. Now, we need to do something with the move, the on move, and the finished functions. Okay, so our move is going to say B is triggered equals B triggered. So we can change the state accordingly. And then let's say if I am triggered, I want to do something. So let's take the movement timeline, and we're going to play it. And if it's not, then we're going to say reverse. Yeah, I think that should be okay. Actually, sorry, we're going to make this play from start. And we also want to say if it's playing either the reversal or moving forward along the timeline, we want to set the is moving to true. When our timeline finishes, then we can say is moving equals false. And that's going to control the semaphore within our tick to ensure we're not doing things sort of when we don't need to. Okay, so that's going to be the end call of our finish. Now the actual move, we want to get the float value along the curve. So let's create a const float. This is going to be our position float, which comes from the movement timeline get playback position. Let's actually call this playback position, so it's Easily understood. And we're going to create a another value, which is the curve float based on the playback position. So this is going to be our curve value, and it's going to be based off the move curve get float value, and you can see we pass in a time. So we want to pass in the playback position. So where are we? Wherever we're at, grab its position and then get me the float value from that curve. Once we have that, we can then say, okay, if our movement type equals location, do something. Else if our movement type equals rotation, do something else. So in our case, we already have these two methods, update rotation, update location. So we're just going to make a call to update location, and we pass in the curve value, update rotation, curve value. Okay, so let's just look over what we got going on here, make sure we're not missing anything. Previously. Okay, so now we can actually change the position of the mesh that this component is referencing. Okay, so what are we going to do for that? For the rotation, what are we going to do? Well, actually, for both of these, we can say if is reversed, then curve value equals curve value. We're just going to take, actually, let's make this not a const, because then it won't get updated. We're just going to take whatever value is being passed in, and we're just going to negate it. Okay, so that's going to handle our reversed state. Now, let's do update rotation next. So, to update the rotation, we want to get the current rotator. Rotator. New rotation equals get relative rotation. And that's going to basically grab our rotation relative to whatever parent that static mesh is attached to. And then we're going to say switch on the, oh my goodness, rotation axis. And that is going, actually, sorry, not rotation axis. What do we call this thing? Rotate axis. My goodness. So we're switching on the rotate axis. And let's see if this auto-completes for us now. No, it didn't. That's fine. So either way, we're going to make a couple of case statements. For the pitch, let's do a break. Pitch, break. Okay, let's do another case for the roll. And for the yaw. Okay. And just the default one. Okay, so that's going to handle our rotation types. And then what do we do with this? Well, with the pitch, we're simply going to say new rotation equals new rotator, and it takes in a curve value as our pitch, and 0.00 for the yaw and the roll. And that way we're not affecting it to however it's related to the parent object. Okay, so for the roll, you can probably guess we're going to do the same thing. Instead of the yaw, we're just going to include the roll. And lastly, we're going to do the same thing for the yaw. Curve value 0.5. Okay. So that updates our rotators, and I was missing a bracket there. And then lastly, we want to set the relative rotation of the component we're working on to the new rotation we just created. So there we go. That's going to update the rotation and hopefully get our door swinging outwards. Okay, so for the location, it's very similar, except we're going to get the relative location, and we're going to set the relative rotation location. Oh my goodness. Okay, so let's get the new location from the relative, not rotation, relative location. Okay, and then we're going to do another switch on the location axis. And we're going to have a case on the X. Break. Don't care about that. Let's do another case for the Y. Case for the Z. And always make sure you have a default with something. It's just good practice. Okay, so there's our cases. And what we're going to do here is we're actually going to say, okay, at the end of all of this, so my previous timeline value is going to be our curve value. Said relative location is going to be our new location. And here, what we're going to do is we're going to say new location X. And what we're essentially adding is the difference between our previous location and our current location, because the curve ends up being sort of cumulative as the numbers come in. So if we start at 0 and 1, you need to always ensure you're adding the delta between the two positions, not the next number on the curve. Otherwise, you're going to like exponentially move things too far. So what we're doing is we're taking the current value and we're subtracting the previous timeline value. And then we're holding out that value for the next operation. And similar to our rotator, we're going to do the same thing for the Y and the Z without affecting the other parts of our vector. So let's recompile, make sure there's no exceptions, and then we'll start jumping into our pressure plate trigger object. So recompiled, nothing's going on with the movable static mesh component. Let's now jump into our pressure plate trigger object. Okay, so this guy is going to require a couple of things. It's going to require two meshes. So we want sort of a base mesh that's going to represent the thing that is going to then have another mesh either go into it or rotate it or what have you. In our pressure plate case, we really want two meshes. So we want that static mesh at the bottom and then something that will go in and out, which is going to be a movable mesh component. So I'm in the header for the pressure plate. Let's go ahead and add in a couple of these properties. So let's make a new static mesh component. This is going to be our base mesh. And it's going to be a new property, edit defense only, blueprint, read only. Let's do the meta accessor of allow private access equals true. And the category of, let's say trigger. Okay, so there's our base mesh. Now let's do the same thing, but for our new movable mesh component. So it's going to be movable static mesh component. And let's just bring in that header file. Cool. So there's our movable mesh component. Let's add in a boolean for B is disabled, so we can control the state of it. Maybe in certain cases we don't want the pressure plate to always be available to us. So let's steal this property definition and just get rid of the meta. So there's disabled. Let's also do, what are we going to call this? A boolean that resets the trigger. So in certain cases, we want the pressure plate to go in and stay in and activate a thing and permanently leave it in that state. In other cases, we want to move off the pressure plate, and then when it goes back up, it will revert the state of the object it's interacting in within the world. So that's what this boolean is going to control. And let's also do a T array of references to tags of actors we want this pressure plate to affect. So we can have one-to-many things in the world that we're going to be interfacing with. So this is going to be called our target tags. Okay, so we have our base mesh, our movable mesh. You know what? We need another component, and this is going to handle the overlapping with our player when we actually step on the pressure plate. So I'm going to use a sphere component for that. And it's going to be our overlap component. Okay. And is there anything else we may need here for properties? No, I think we may be okay. Now, as far as method signatures go, well, we have an overlap component. So we're going to have to add some on begin overlap and on end overlap calls. And we're going to have to also include, oh, that's what we're missing, just the method that actually activates the object we're dealing with. So let's make a new function. Actually, no, we're going to make this one private. So this is the one that the begin and end overlap are going to call to do stuff with our object. So let's say let's call this trigger. Or no, what do you want to call this? Interact, and bool B is interacting. Okay. So are we actually doing something with this object? Let's go into the C++ class, and let's bring in some of these methods here, as well as these component definitions. So our base mesh is going to be our root component. So we're just going to create a default object, static mesh component, and that's our base mesh. And we're going to set this to be our root. Then we're going to say our movable mesh, new movable static mesh component. So there's that, and this guy is going to be a child of the base mesh. So set up attachment base mesh. Cool. And the overlap is a sphere component. So overlap, it's the overlap area, and we want to attach this guy to the movable mesh. So that way, if it goes up and down, we can trigger the end overlap sort of correctly. And we did something similar to our spline tutorials, where we had to move along the spline with the mesh, so we could catch things as the player kind of moves along. And that's going to be the movable mesh. And I think that may be it for the constructor. Yeah, and then we can go and start defining the begin play to introduce the on begin and end overlap events. So overlap component on begin component begin overlap. We want to add a dynamic call to on begin overlap. Actually, sorry. This class on begin overlap. And we don't have these methods yet, but we'll get them in shortly. And on component end overlap, we want another callback, this time to this class on and overlap. Okay. So let's get the method signature for this component. Because I don't remember off the top of my head how this whole thing goes. So there's this bit. And we're going to create a new method on begin overlap that takes in all of these parameters. So what I did here is I quickly navigated into the actual component. Primitive component to get the begin overlap signature. And then there's the end overlap signature as well, which we can just take these parameters and put them in our on end overlap call. There we go. Semicolon, get rid of that. And these guys should now be a little bit better, a little bit happier. Let's make these function as well, just in case, because sometimes you may run into situations where non-annotated methods are not able to be referenced by the engine for various reasons. Okay, so we have our begin and end overlap handled. We don't actually have anything triggering the interact. So what we want to do now, actually, let's add these two new methods. There we go. Two new methods. And what do we want to do here? So we want to say, okay, so if I am not a disabled component, and what else do we want to say? If I am not triggered, And sorry, this is actually not in the interact. This is in our begin overlap. So, and B, oops, B is, what do we call this thing? B reset trigger, B is disabled. Oh, okay. So let's just, let's just do not disabled. And we'll worry about some of this other stuff in a bit. And what do we want to do? Well, we want to say movable. I think I'm going to change the spelling of this component. Yeah. Just do a quick rename. Oops. Movable mesh. Okay. So movable mesh. True. And on end overlap, let's do false. So that's going to affect it's going to affect the single mesh component that we have on this actor and make its perform its movement operation. Okay, so that's going to affect this thing, but we also need a call out to the actors out in the world that we want to interface with. So remember, we created this target tags property, and now we need to do something. So we're going to say, okay, if we are interacting, then we're going to call the interact method with a true, and with a false over here since we're stepping off the blade. Okay, so what is this going to do? Well, let's use gameplay statics. And we want to say get all actors with interface. So we have this interactable interface, and we're going to basically say, get me back everybody that has it. And then let's compare them against the target tags that we have against their tag. And if they match up, perform the interact operation on those guys. So what does this method take in? Well, it takes in a world object, the interface we want to look up against, and an output array of where it's actually going to suck in all these actors. So let's create a array of actor pointers. And these are the interactable actors. So our context is I guess, no, our context is the world. And the interface we're using is interactable interface. We don't have that reference yet. So there's our static class and our pass by reference array here. Okay, so if we have any actors, what we're going to do is for every actor, we're now going to say, what are we going to do? We need to grab the tag from this guy. So fname, let's just call it interact tag equals interactable interface, and then okay, let's go back to this in just a second. I realized we didn't define any of our interface signatures. So let's go ahead and put that in, because otherwise this is going to just keep complaining. So interactable interface. What do we want this thing to do? Well, we want to get our tag. So we want a new function, blueprint native event, and blueprint callable. Category is going to be interact, and this is going to return fname get interact tag. Okay, so this is going to force our objects to implement this method signature so we can actually return a tag. And then we want another method that is going to trigger the interactability with our objects. So let's say void interact and bool b is interacting. Let's just do that. Be interacting. Okay, so these are the two methods we want all of our objects to implement if they inherit this interface. But what this really gives us the ability to do now is to have access to these signatures. So for our tag, we want to say execute interact tag. And you'll notice the way this works is, rather than casting to a specific object, I'm basically saying, hey, for this interface, execute this method, and the input parameter is the object that we're performing this execution on. So what should happen, just looking at my notes here, is this guy should, for any actor that has this interface, it's just going to run this method on. We'll get the interact tag, and then we can say, okay, for the tags that we have, do I have any that match? So I want to iterate over all of them. So this is my tag, and I'm going to say target tags. And we're simply going to say if interact tag is equal to the tag, and then we're going to pass in a case sensitivity specifier. So name ignore case. This way, if people have like little typos or whatever, it's still going to work. So we found the right thing. Then we want to do the interact operation on that actor. So we would do the same thing. interactable interface, execute get, or sorry, not interact tag, execute interact. And you'll notice this method takes in two parameters. So the thing we're executing it on, as well as the parameter we're specifying. So B is, actually, let's make this, sure, B is interacting. And let me just make sure that is the same over here. Okay. Cool. So going back to our pressure plate object, we now have a call to all of the interactable actors it's going to affect. We have some of our moving activities occurring. And I'm trying to think if we need to throw in anything else. Oh, and you know what? We're missing a trigger state for this. So let's do a private. Bool B is triggered. And then we can say B is triggered equals true. and B is triggered equals false. And then we basically want to say only do this if we're not triggered and we're not disabled. So okay, so if we haven't triggered it yet, then trigger it, do its work. Once we step off, set it back. Let's recompile and then work on our last class. Okay, so one compile later, everything looks good, and let's finish off this last class before we go back to the editor and see how badly this either works or explodes. So for our moving static mesh actor, this is going to be the thing that represents our doors, our windows, and a couple of other components. So let's go ahead and start defining its internals. So the first thing it's going to do is leverage our new interface. So there's the iInteract interface. Why is that not iInteract interface? Okay, that's fine. Don't autocomplete for me. Let's do your puzzle tutorial / interface. Sorry, live interface and interactable interface. iInteractable interface. There we go. Okay, so there's our reference. Now we are going to override a couple of the methods. So we have get interact tag and interact. There we go. So we got these two methods that we're going to be overriding from our interface. We have the begin play, we got the tick. Now we need to define a couple of properties for this object. Okay, so because this is going to be similar to our pressure plate where we want one or many static meshes and then some that are movable, we're going to keep it kind of simple, and I'm going to again do a property visible anywhere, blueprint, read only, meta, allow private access equals true, and category equals moving. So this is going to be our base static mesh component. Base mesh. Let us copy this and make a movable static mesh component. Movable static mesh component. Typos. Okay. So movable static mesh component. That's going to be our movable mesh. We need a an interact tag to ensure this getter is actually doing his work. So let's do uProperty edit defaults only. Blueprint. Let's just do read only. Category equals moving. So there's our interact tag. And let's do a disabled call just to be preemptive. So it's going to be a bool is disabled. Okay. So going into the CPP file for the moving actor, let's bring in some of these definitions. Okay, so our tag is going to return the interact tag, and our interact implementation is simply going to say, what is it going to say? If not B is disabled, then we want to say movable mesh move, and we're going to pass in the B is interacting parameter into it. Let's go ahead and also ensure that these objects are instantiated and initialized. So base mesh, create default subobject, static mesh component. Base mesh. And that's going to be our root component. And then our movable mesh is going to be attached to the base mesh. And our movable mesh, we need to instantiate it. Let's do that. And let's do this so we're more accurate. Pressure plate. Yeah, let's do... Okay. So I think we have our movable object defined. Got a couple properties on it. Our pressure plate should now do some direct interaction with that. Let's recompile and jump into the editor, see what this looks like. Okay, so back in the editor, let's go ahead and start creating some of these blueprints from these new classes. So let's find our pressure plate first. Pressure plate. And let's do another class that is going to represent our movable, where did I go? Moving static mesh actor. And moving static mesh actor. Oh, actually, sorry. Let's make this a BP door, and let's duplicate this for a BP window. Okay, so let's look at our pressure plate first. We have our meshes, we have our component. We also need to define our target tags. And for our movable mesh, we've got some curves and rotation, location stuff we got to define. And here's that that drop down that picks different other drop downs based on the enum contained within. So that's our little conditional statement. Okay, so we don't have a move curve. Let's also do that. Let's make actually a new folder called props. We're going to move all this crap in here. And let's make a new curve. So if you've got a miscellaneous curve, we're going to create a float curve. So this is going to be our pressure plate curve. And let's start defining this pressure plate. So our base mesh is going to be, I'm actually using this Cinti Studios Polygon prototype pack for some of these assets, just because I find they're a little bit more interesting than the standard stuff that comes with the package. Unfortunately, I can't package it up with the tutorial content, but feel free to grab it off the marketplace. It's only a couple bucks, but all of this logic applies to any sort of model definitions where we're not really concerned too much about that. I'm just trying to keep it kind of aesthetically pleasing for myself. So what we're going to do is we're going to just take a look at some of these static meshes, and I'm looking for a floor. So what we're going to do is use the floor mesh to give us sort of a starting point. And for the movable mesh, we're going to use it's a plate, metal plate. So let's make this a little bit bigger. 1.2, 1.2. Let's make the plate go over it. Ish. Okay, let's make the bottom one actually just a little bit bigger. Yeah, I guess we don't want to inherit the scale. So let's do 0.8. We can make this one now. Okay, there's our pressure plate. Let's make this overlap radius just a little bit bigger. Okay, and let's see what this looks like in relation to our character. We just need to make it a little bit bigger. Okay. Yeah, I think it's pretty flush with the ground. Okay. So there's our blueprint. Our overlap component. Yeah, we'll leave it as overlap all dynamic for the time being. Our movable mesh has no curve definition, so let's give it a curve definition. And then the movement type is going to be the location, because we want it to move up and down on the Z here. So let's make this location. Let's make this Z. And let's make this curve. So let's add a key. So at 0, 0, it is there. And let's say at 2, 2, it's there. What am I doing? Okay. So there's a curve. We have it assigned. We're going to go up on the Z-axis. What else do we have? We don't have any target tags. We'll leave that alone for now. Let's save and make sure this works. So as you can see, it's very slow, but it is raising it up and down. Now, we want it to go the other way, so we can flip, where was it? On the movable object that we want to go the other way. So we're just going to set the reverse flag. So there we go. Over 2 seconds, we descend 2 points down. And there's our pressure plate. It's a little slow. So let's make it, actually, sorry. Let's make it over 1 second move to 2 points. A little bit faster. What about 0.75? What does that look like? Actually, let's go half a second. 0.5. Okay, that's doable. It's definitely showing how our movable component is just doing stuff on its own. Now let's go ahead and replace this door and these windows with new components that are going to be affected by our interact tags. So to do that, we already have our window. And let me just figure out wall window as the base object. Okay, and let's make it blue. The movable component is going to be, what is this, mesh? Floor 1, 1. And let's rotate this guy. So one thing you're going to have to notice with these movable components is where the pivot point is on your static mesh. So in this case, our pivot point is right on the corner. So we can do operations like this. If you rotate it out this way, it's always from that corner. So in this case, we're going to make our windows sort of go up like storm shutters, essentially. So let's set the rotation back to nothing. Let's move it over so it's aligned a little bit better. Like so. And then rotate it downwards 90 degrees. Let's maybe move it out here. What is that going to look like? Okay. I think that might be good enough for now. So our movable component is now going to use the roll as its rotator. So we're going to have to give it a different curve. But we're going to say rotation, and we're going to say roll. And let's give it a curve. So let's make a new curve. Curve, float curve. And this is going to be the, window curve. So we want the window to go maybe like 115 degrees. So at 0, 0, again, we're nowhere. And at 1, let's say we're at 115. So that means we'll rotate 115 degrees, which should put us like somewhere in there. Maybe we should get higher. Okay, let's try buck 35. Okay. So window, let's give it a curve, window curve. And now for these windows, we want to give it an interact tag. So we're going to call this window. And on the pressure plate, in our interactable or our target tags, we're going to say window as well. And actually, let's add the other one for door. Okay, so there's our window. Let's go ahead and do the same thing to our door. So let's give it a tag of door. Let's give it a base mesh, which looks like, what is that? Wall door 2, 3. There we go. There's our door. Let's make it blue as well. And our moving component is also a door. And we're going to shove it over a bit this way. And then this door is going to rotate outwards like so. So let's just push it over a bit. Make it stick out. Okay. And that is going to rotate on the yaw. So rotation, yaw. And then we also need, you know what, let's use the same window curve. So it's going to go 135. It's going to be like out here somewhere. Okay. So our door is labeled. Our mesh component is set up. This is all okay. Now let's swap out these doors and windows. So let's get rid of that. Let's get rid of that. Those guys are gone. Let's pop in our new interactable window. Okay, there's one. There's the other one. Let's just rotate it outwards. And just a little bit of positioning. Okay, so there's the windows, and let's get rid of the door. Door frame gone. And let's put in our door here. So rotate it 90 degrees. Make sure it's generally in alignment. Not to be perfect. We just don't want our character getting in this little house without our intervention. Okay. So the good news is our door is working, but our windows are reversed. We want them to be closed and then open. So we have a little bit of a bug where our windows, they're starting okay, and then they're rotating outwards. Now, I don't know why I thought the reversal was going to fix it. Let's just observe this. Okay, give me a second here, and we'll take a look at the code and see where the issue is. Okay, so I found the issue with our rotating windows, and the problem was, like a dummy, I assumed that the rotator wouldn't have to use the same logic as the location update, where we keep tabs on the previous timeline value as well as sort of the starting point. So we're going to change this logic a little bit for the rotator. So rather than passing a new rotator, we're simply going to say the pitch value equals the curve value. So what we're going to do is we're going to take this logic here, where the previous timeline value is set, and we're going to put it in the on move. And then right before that, we're going to create a new float, adjusted value, where we take the curve value and we subtract the previous timeline value. So basically this work over here. And then we can take out this bit here from the location. And in our rotation, we can do the same thing. So the pitch is going to add the curve value. The roll is also going to add the curve value. And then lastly, we're going to do the yaw. and curve value. Okay, so that comes in, we do the subtraction, we pass in our adjusted value into our updated location and rotation, and then the previous value is going to be our whatever the curve value was we were passing in initially. Okay, and the other problem that we had was when we stepped off and on the platform, the pressure plate rather, what would happen is this play from start and this play in this reverse would do a little bit of jittering, because if we step off and on and there's still an animation going, the play from start would cause it to go all the way back to the beginning and then a replay. So what we want to do here is we're going to say if our timeline is reversing, so if it's already from here, we already triggered this the sort of closing step. We want to say move timeline play, and if we are truly starting from scratch and nothing's been playing, we want to play from start. That's going to give us just much smoother transitions with all of our movable components. So let's recompile and make sure this works. Okay, so back in the editor, let's make sure everything is working as expected. Awesome. So there's our windows that are going to flop up, our door, and we still can't get in because things are just moving too fast for us, but everything is working as expected. Our pressure plate's going down, our windows are opening. You know what, let's make this door actually, let's reverse this so it swings outwards. Still can't get it, a little too far. But what we can do in order to make this problem go away is on our pressure plate. If you recall, we have this reset trigger flag, which I don't think we're leveraging. So let's just go back to our code and make sure it's operational. But essentially, if this is checked off, then it should only reset. So our reset is not working. Let's go back to the code and get that fixed. Okay, so back in the code, we do have this reset trigger flag, but it's not being used for anything. So what we're going to do is in the end overlap, we're going to say if I'm not disabled and be reset trigger, then we want it to restart itself. If it's already been triggered, then we just want to leave it in the on state, and everything should be okay. So let us just recompile and make sure this runs in the editor. Okay, so back in the editor, let us make sure our reset flag works. So there's with the reset turned on. And as we step off, things get closed up. And then if we do it without the reset, look at that, everything stays open. So there we go. We have gone ahead and created a couple of components, an interface, and a couple of actors, and all of a sudden we have sort of the basic mechanic of little puzzles. The next tutorial, we're going to look at how to actually pick up an object and drop it onto the pressure plate so it can interact with it, and then our character can run inside and do whatever nefarious things he's going to do. Again, thank you for checking out our content. Thanks to all the Patreons who have been supporting us, and I look forward to seeing you guys next time.